Assalamualaikum warahmatullahi wabarakatuh. My name is Bintang, and today I'll be the one who will present the research-based learning of Group 2, and I'll be the one presenting by myself. So we'll go to the next slide. Okay, so for our group, we have 7 members, and today, actually, I'm here with Malvin, who is monitoring the presentation. Okay, so we can go to the next slide. All right, research. So there are 2 main purposes, in which first is to determine the diameter of natural fibers using optical measurement techniques, and the second is to set up the diffraction phenomenon experimental apparatus and analyze the diameters of the various natural fibers based on the diffraction pattern shown at the screen. Okay, so next is the brief theory. So there are quite a lot of theory, but I'm going to explain it briefly. So first is the diffraction, in which it is a phenomenon of a bending wave as it passes through an aperture or encounter an obstacle. So this diffraction is actually also a form of interference phenomenon, and the resulting of the diffraction pattern can provide valuable information such as the structure and properties of material. And so this diffraction has a very high utility, although even though it is a fundamental concept. And then, of course, in physics, it has lots of equations, including this diffraction phenomenon, to which diffraction has its own equation, and it is a mathematical formula that shows how wavelength and also the size of the aperture or obstruction affect the intensity of the light that is diffracted by it. And then based on the properties of the observed interference pattern, the equation can be used to determine the diameter of an item. Okay, so next is the experimental apparatus. So there are quite a few. First is the red laser pointer. For our experiment, we use 650 nanometer. And the next is the tree fibers, coconut, grass, and plant. And then is the millimeter screw for our optical measurement. And the next is the millimeter block for the screen, ruler, pencil, cardboard, scissor, and tape. Next is the procedure. So we did quite a few procedures for our experiment. The first procedure is we need to find a sufficiently spacious room with low light, and then we need to set up the experiment by putting the laser, the slit fiber, and the millimeter in, and then we need to turn on the laser. And then we need to adjust the slit position to create the diffraction pattern on the screen as clear as possible. And then we need to mark the order N of the diffraction pattern and the center with a pencil. And then we need to measure the distance from the center to the marked order. And then we need to measure the position of the adjusted slit to the screen. And then next is 2 remaining steps, in which we need to calculate the diameter with a known diffraction equation, and then we need to replace the fiber if necessary, in a condition when not all the fiber has been measured. Next is the calculation. We have 2 main formulas. First is the diffraction equation, in which it is diameter of the fiber times sinus theta, and it is equal to n order number times the wavelength of the laser beam. But since we don't measure the angle, we switch the sinus function to become y over L, in which y is the distance to the n order from the center, and then L is the distance from the fiber to the screen. And the next is the resulting data. This is the result from the diffraction experiment. I'm not going to mention one of them to optimize the duration, but I'm going to explain what each column mean. So y is the distance from the center to the nth order, and then L is the distance from the slit to the screen, and N is the selected order of the diffraction pattern, and then lambda is the wavelength of the laser, to which it remains the same for all slits, and then the diameter, in which we get from the diameter equation from the known other parameters. And the next is the result from tools of measurement. So for our tools of measurement, it is the optical measurement, and we use the millimeter screw, and the resulting on the data on the table is the measurement that we get from the measurement. Next is the analysis. So for our analysis, we did an analysis on the data from the measurement with the diffraction method and also with the optical measurement. So what we get is that from table 2, in which it presents the data from the diffraction method, is that there is a variation in the diameter of each slit, and also in table 3, it is the data from the optical measurement. And when we compare from table 2, when we compare table 2 to table 3, there is a pretty significant difference between measuring between the data of the measurement. And in order for us to get the diameter of the diffraction method, several parameters must be known or measured if necessary beforehand. And such parameters are the wavelength of the laser beam to which it has been known at the time of the purchase, and then the order number, distance to the nth order, and distance from the fiber to the screen. And all data which must be measured are measured in centimeters, except the wavelength, which happens to be known without measurement. And the next is finally the conclusion. So for conclusion, is that we get that to determine diameter of a very thin object, it is possible with optical measurement technique, but it is limited by human perception, and so may give an accurate measurement result. And so to get a more accurate way of measurement, we might need to opt to the diffraction phenomenon. And with diffraction, it is possible to get more precise measurement of thin object. As to get the diameter is that we need to only do algebraic calculation at the same time. And at the same time, the other variables are measurable enough by the human perceptions. And such variables are like the distance from the slit to the screen, the order number n, distance from the center to the nth order, and the laser wavelength used in the experiment. And then when we already got those variables, we can do a simple algebraic calculation, and hence we will get the diameter. And from the result of this experiment, we can conclude that measuring thin object diameter with optical measurement techniques gives inaccuracy, and should opt for the diffraction method for more accurate measurement. Okay, so that is all for presentation of our group. Before we close our presentation, we'd like to say thank you to Mr. Warrior for all of the knowledge that you've taught us this semester. And that is all from us. Wassalamualaikum warahmatullahi wabarakatuh.